2 says feeding a crowd revisited. All right, so it says a recipe says that 2 cups of dry rice will serve 6 people. Now our job is to complete the table and answer the questions. We need to be prepared to explain your reasoning because I'm going to be calling on people to tell me how they got these numbers in here, all right? So they give us some crucial information right here that says 2 cups of dry rice will feed 6 people. So given that information, we should be able to find a constant of proportionality. Remember, the constant of proportionality is what we multiply the left side by to get to the right side. And once you find that constant of proportionality, then just apply it to the rest of the table to fill in all the missing parts. All right? Question, Cloud.
Answer.
Don't give you the answer. I want you guys to do it on your own first, then we'll go over the answers as a class, okay? Ready, set, go. On your own.
Wait, you said 29, right?
Yeah.
I learned.
We're actually doing the first group. Let's go.
Nothing.
So answer the question. And then tell me if it's X, what are we going to do with X? Yeah, there you go. Write it down. You know, X represents all numbers that it potentially be. So what are we doing for every single time to get from left to right?
Yeah, so X would be 3.
X is no exception.
So then maybe I just thought that would be X number.
We'll talk about that later. I don't have time to really tell you about that one right now, so we're going to go ahead and move on. And we'll come back, I'll talk about the homework at the end. All right, so if I have 1 cup of dry rice, well, first of all, what is the constant of proportionality in this table? So in other words, what do I have to multiply rice by to get to people? Richter?
3.
3, exactly. I'm multiplying everything, all the cups of rice by 3 to figure out how many people I can feed. And if that's the case, then Sienna, if I have 1 cup of dry rice, how many people am I going to feed? 3. Good. Now, if I have 3 cups of dry rice, then how many people can I feed with that, Angel? Where you at, Angel?
Angel went to go get his book.
Okay, so let's hear from Jocelyn. What'd you get?
9.
9, yeah. 3 times 3 is 9. Then if I have 12 cups of dry rice, then Angelina, how many people can I feed with that?
It's 36.
Yeah, 36 people, okay? And then 43. If I have 43 cups of dry rice, then Morgan, how many people can I feed? 129, exactly. All right, and then X, if I have X numbers. So this one is kind of difficult because people are thinking, well, what does X represent? Well, X, whenever you have a letter in math, it represents all numbers, or any number, really. So X in this circumstance is going to represent any number of cups of dry rice. So, but we follow the exact same pattern. So if I had 1 cup of dry rice, I multiply that by 3 to figure out how many people I can feed. If I have 3 cups of dry rice, I multiply that by 3 to figure out how many people I can feed. If I have 12 cups, I multiply by 3. If I have 43 cups, I multiply by 3. So I'm doing the exact same thing with X. So if I have X numbers of dry rice, what am I going to do to X, Greg? I'm going to multiply by 3. So when we multiply a number by a variable, there's a couple different ways we could do that. I saw some people do this. X times 3. But the thing is, if we put an X and a multiplication symbol next to each other, look, it's kind of confusing. It just looks like 2 X's. So there's a different way we could write this. We could write this like this, X, and use the dot times 3. We could do that. But in algebra, an easier way to do it is if we put the number first, followed by a letter just to the right of it, that tells us, if I read that, I say 3x. And I read that as 3 times x. So that's how I would write this. I would write this as 3 times x. Now, if we were to write an equation, so an equation is an algebraic term, whenever we have an equal sign, everything on either side is equal to each other. So if I had 3x on one side, that would mean that I multiply 3 times the number of cups of dry rice, and that's going to be equal to the number of people. So then we need to assign the number of people a letter as well. So let's say I assign the letter y to represent the number of people, then I could say 3x is equal to y, where x is equal to the number of cups of dry rice, and y is equal to the number of people. Okay, so Greg, I need your eyes on the board. This is very important. So when we're talking about algebra, there are 2 different variables. Now, variables are things that can change. Okay, so this one right over here, x, when we multiply it by 3, because something's happening to it, we would call that the independent variable, and then y, we would call this the dependent variable. And we would call this the dependent variable because the number of people we can feed is dependent upon how many cups of dry rice that we have. Okay, so again, this is just a really basic equation here with a dependent and an independent variable. All right, so let's look at some other relationships to see if we can make equations with those too. Okay, next one says, a recipe says that 6 spring rolls serve 3 people. So we're going to complete the table as we answer the questions, and we're going to be prepared to explain our reasoning. So I want you guys to do the exact same thing you did in the last one, but this one is a slightly different relationship to get from spring rolls to number of people. Okay, so again, find the constant of proportionality and apply it to answer all of these questions. Okay, on your own, ready, set, go. If you need to use a calculator, you can. Make sure you borrow one that corresponds to the number of your table. No, because that would be 2 times n, but we're not multiplying by 2 to get from 6 to 3, are we? Yeah, so you got to take n. Hey guys, on this one, think about what we're doing to get from the left-hand side to the right-hand side is not multiplying by 2. So therefore, if you take n and you multiply by 2, that's kind of going the opposite direction. What's up? Yeah, you should ask me earlier. Remember that kind of lesson. Let's go. Go. All right, let's try to fill this in together, see if we can find any differences between this table, this relationship, and the last relationship we just talked about. So, start off with Maddie. What are we doing to get from spring rolls to people on this one? We're dividing by 2. I would totally agree, because we take 6 and we divide that by 2, and that's how we get to 3. So that's the first step, is we need to figure out what the constant of proportionality is, and then we know that the rest of the left-hand side is going to be divided by 2 as well, because we do the exact same thing. That's why it's the constant of proportionality. It's not changing. It's going to be the same thing. All right, so help me fill in this table. So if I have 1 spring roll, how many people can I feed? Let's hear from Catherine. What do you think?
spring roll?
Yep.
0.5?
Yeah, we could say 0.5 or 1/2. Now, a lot of people are like, well, how do you feed a half of a person? Well, this might be if you just gave someone a spring roll, they might eat it and say, well, that was delicious, but I'm not quite full. Maybe you just fed half of their appetite and they're still hungry. Or maybe this is like a kid we're talking about or something like that. But either way, yeah, it'd be 0.5 or a half. Now, if I have 10 spring rolls, how many people can I feed? Morgan?
Oh yeah, sorry, I was looking at the wrong chart. 2.
Not quite 2, no. So on all these, we're dividing by 2. So Angelina, how many people can we feed with 10 spring rolls?
5.
Yeah, it's 10 divided by 2, which is 5. Good. Now, if I have 16 spring rolls, how many people can I feed with that, Cloud?
8.
Yeah, good job, 8. Now, if I have 25 spring rolls, how many people can I feed with that, Richter?
12.5.
Yeah, nice, good job, 12.5. All right, now we get to this letter N, and N is going to represent the number of spring rolls. So if I have N amount of spring rolls, then what should I do to N to find the number of people? Sienna, what'd you put? Or did you get that one?
You should divide it by 2.
Yeah, exactly. Yeah, nice. Sienna recognized that it doesn't matter how many spring rolls I have, I always divide it by 2. And so it doesn't matter if it's 1, 6, 16, 25, or N number of spring rolls, I'm still going to divide it by 2. So I can write this a couple of different ways. I can write N, and then the division symbol, N divided by 2. Okay, another way that is, the way we can write this, that you'll often see in algebra, is we would go N over 2, because N over 2, when you put it in a fraction form like that, that tells us that we're going to take N and we're going to divide it by 2. Or you could look at it as, another way you could look at this, as you could say, 1/2 of N means 1/2 times N. So remember, when we're doing a multiplication problem, you just put the letter just to the right of 1/2. So you could say 1/2 of N is the same thing as N over 2, same thing as N divided by 2. All three of these mean the same thing. So now if we're going to try to write an equation to represent the situation, equation, remember, has to have an equal sign. All right, and on either side of the equal sign, we have to have things that are equal to one another. So on one side, I might put my N over 2. Okay, that's N divided by 2, and we know that that's going to be equal to the number of people. And again, number of people, maybe we just assign that a letter. We could say even Y, or we'll use P. So N over 2 is equal to P. Okay, and this is an equation that represents the situation. So if I have a number of spring rolls, I divide that by 2, and that tells me how many people I could find. So that would be an equation to represent this relationship. Okay, that's what we're talking about. Whenever we're in algebra, whenever we have equations, we're always talking about relationships between two things, how one thing affects another. So again, the dependent variable is the number of people, because it depends upon how many people or how many spring rolls we have. Dependent, independent. The dependent variable is typically on one side of the equation by itself. All right. So how is this table, how is completing this table the same, and how is it more likely, what I want to know is, how is it different than completing the last table? Nora, what do you think about that? How is it different than completing the last table?
So 6 was in the number of spring rolls, and 3 was in the number of people.
Uh-huh.
But for the cups of dry rice, it was 2. So it's pretty much just flip-flopping the numbers.
Okay, yeah, so it's kind of like flip-flopping the numbers, or in other words, we can say that the left-hand side of this table had numbers that were bigger than the right-hand side of this table, whereas if we go back to the first one, the cups of dry rice, the smaller number was on the left-hand side and the bigger number was on the right-hand side. So in one, we're multiplying by 3 to get from left to right. Richter, hold off on that for just 1 second. And on the other one, we're dividing by 2 to get from spring rolls to people. So that's kind of the difference, is in one we're going from a small number to a bigger number, and the other one we're going from a big number back to a small number. All right. Next question we're going to look at has to do with this map. Now this map shows us the route that a plane flew from Denver to Chicago, and it tells us right here, a very important piece of information. It tells us it's going at a constant speed. That tells me we're going to be talking about a proportional relationship here. Okay, and it says it took the plane 1.5 hours to fly 915 miles. And those are the numbers that they put for us in this table already. Now, all we need is two numbers and the fact that we know it's going to be a proportional relationship. We know it's going to be a constant speed. All we need is these two numbers, and then we can find out any number of miles based on time. So what we're going to do here is we need to figure out how many miles per hour they're going. All right, so in order to do that, miles per hour, we would call that a unit rate. And a unit rate is when you compare two different things, and in this circumstance, we're comparing hours and miles. But a unit rate is when you compare two things and you want to know what one of the things is in terms of one. So here we're trying to find miles, which is more than one, per hour, which is just one. Okay, so again, whenever we're trying to find a unit rate, you want to put the thing that you're trying to find one of on the bottom. So here, are we trying to find 1 mile or 1 hour? 1 mile or 1 hour? JJ, what do you think? Miles per hour. Yeah, we're trying to find how many miles we can go in 1 hour. Okay, so we want to put hours on the bottom. Okay, we always, whatever we want one of, we put it on the bottom. So if we're trying to find miles per hour and they give us 1.5 hours, we're going to put 1.5 on the bottom. Okay, and then miles goes on top. So 915 miles, okay, in 1.5 hours. And then the way you find a unit rate is you just take, once you set it up like this, then you just take the top and divide it by the bottom. And that'll tell us how many miles we can go in 1 hour. All right, so that's the first thing you guys need to do is find how many miles they can go in 1 hour, and that's our speed. And then once you find the speed, that's also our constant of proportionality. And once you find the constant of proportionality, you can fill in the whole table. So use your calculators, work on your own to fill in this table. I've already given you a way to set it up and to find that constant of proportionality. Okay, ready, set, go. Yeah, what's up? Nope, remember, no, we're going to divide the top by the bottom. Divide the top by the bottom. Here, top by the bottom, top by the bottom.
Mr. Sugar, can I look at that thing?
After you fill out this, yes. Yeah. Top divided by the bottom, that'll give us speed. Okay.
Also, I divide the
Whatever I write up on the board, you should be right up there too. So I give you a pretty big hint.
Nelson Mandela.
Yeah, what's up? Well, check this out. So we know that you can go 610 miles per hour.
Are you kidding?
So that means in 1 hour, you can go. Yeah, good. What's up, Angela? Hey, answer yourself.
Yeah,
What's up? Well, no, so look at this. This is 610 miles per hour. That means that you can go 610 miles in 1 hour. So look at this. 1 hour. How far can we go? Yeah. No. 1 at 610 miles per hour. That means every hour we'll go 610 miles. Yeah, exactly. So I agree. That's the speed. 610 miles in 1 hour, miles per hour. And that tells us that every hour goes by, you go 610 miles. Right? So look at this. This first one says 1 hour. 610. Yeah. Okay, so look at this. You guys got 610, right? That means that every hour that goes by, you can go 610 miles. So look, this one's pretty easy. 1 hour's gone by, how many miles? no, it's even easier. 610 miles per hour. That means every hour you go 610 miles. So 1 hour's gone by, how many miles? It's just 610. It's 610 miles every hour. For what? Did you turn any corrections? I just might not have graded them. Together. And I either didn't grade him or you did not grade him. What's up?
I didn't know you said
No, because look what you're doing to get from 1 to 10.75.
So we're saying 10.75. What if we divide 1
Okay. Hold on. I want to work on the classwork first before we get to the homework, okay? Alrighty, I need you guys' help to fill in this table. So if I'm going 600, well, first of all, I think we all found out that we're going 610 miles per hour. That's how fast this plane is going. And if that's the case, then JJ, after 1 hour, how many miles have I gone?
915.
No, that's after 1.5 hours. Okay, make sure you're paying attention, all right? Eden, after 1 hour, how far have I gone?
610.
Exactly. So, check this out. If I go 610 miles per hour, that means every hour that goes by, I go 610 miles. So after 1 hour, I've gone 610. And then after 2 hours, how far have I gone, Riley?
After 2 hours, you would have gone 1,220.
Exactly, 1,220. Now you can find that just by multiplying 2 by 610. Or some of you might have taken that if it was 1 hour here and 2 hours here, you can multiply 610 by 2 to get here as well. Okay, now if I go for 2.5 hours flying on this plane, how far have I gone, Anna? 1,525 miles, exactly. So, on each one of these, I'm multiplying time by 610 to get to distance. So, if that's the case, then if I have t for the number of hours, what do I do to t to find the distance that I've gone, Shane? Yeah, exactly. T times 610. And another way I can write that is just 610t. Okay? That's a way that when I read that, it indicates I take t and multiply it by 610. All right. So, that's time. We said that time, t is going to be equal to time. And then we're going to say that distance is going to be equal to d. All right? So, if we're going to take this and write an equation for it, we're going to say that d, I want to know how far can I go, that's distance, and we're going to set that equal to what do I have to do to find distance. So what do I have to do to find distance here? Olivia, what am I doing here? Well, didn't we just take time and multiply it by what? No, so Olivia, check this out. Look at this number that keeps repeating itself. Didn't we just take time and multiply by 610? Yeah. So to find distance, we take time and we multiply it by 610. So t times 610. Now another way we can write that is distance is equal to 610t. Now this is an equation that represents the relationship between distance and hours. All right, so please do your homework. We will grade that next week when I see you guys next. Other than that, please push your chairs in. Have a wonderful day.